Let us look at some other examples also to understand covalent bond a little more better. Let us take the case of chlorine. The element chlorine, it exists as chlorine molecule, it is a gas. So how does this happen? For this you need to know the electronic configuration of chlorine. It is 2, 8, 7. So chlorine has 7 valence electrons. Only the valence electrons should be represented as electron dots. So it can be represented in the form of dot or by a cross mark. So the 7 valence electrons are represented. Of course, it requires one more electron to be stable. So how does it achieve this stability? By sharing its outermost electron with another chlorine atom. So when it shares the electron, now this chlorine atom has got 8 electrons, 2, 4, 6, 7, 8 when the two orbits overlap. Similarly, this shell will also overlap, and this atom also will have 8 electrons, and that is how chlorine molecule is formed. We can represent this by a line. So once again there is a single bond. This bond is covalent bond, and the compound formed due to covalent bond is called as a covalent compound, which are different from ionic compounds. Let us discuss about it at the end of this particular topic. So in the case of hydrogen we have single bond. In the case of chlorine molecule also we have 2 chlorine atoms sharing 1 pair of electrons. That is a covalent bond. Let us take some other examples. Say oxygen is once again present in the form of oxygen gas in the atmosphere, where 2 atoms of oxygen combine to form a oxygen molecule. Let us take a look at how exactly this happens. So oxygen atomic number is 8, the electronic configuration is 2, 6. So let us represent this. The 6 valence electrons are shown as cross marks, and evidently this oxygen requires 2 more electrons to achieve a octet configuration or a stable configuration. So what can oxygen do? It forms a bond with another oxygen atom, which also incidentally requires 2 electrons for becoming stable. So once again in this case the electrons are shared between the 2 oxygen atoms. So that is how we show the overlap. 2, 4, 6, 8. So this oxygen atom is stable. Similarly, the overlap happens here also, and this oxygen atom also gets 2, 4, 6, 8. So this is what I told you in the beginning. This shared pair of electrons, it belongs to both the elements. So this belongs to both the oxygen atoms. Thus, both the atoms have achieved the stable configuration and they form the oxygen molecule O2. In this case, however, there are 2 pairs of electrons that are shared. We have 1 pair and we have another pair. So we can represent oxygen as like this. Because there are 2 pairs of electrons, we represent it using 2 lines. This is what we call as a double bond. So a double bond is formed when two pairs of electrons are shared between two atoms. This is one pair, this is the second pair. So we get double bond. We also have cases of triple bond. Let's take a look at that example. Best example is nitrogen. Nitrogen is also a non-metal. Nitrogen has the electronic configuration 2,5. So this can be represented as 5 valence electrons, 2, 3, 4, 5. So in order to achieve a octet configuration, it requires 3 electrons. What does it do? It shares these 3 electrons with another nitrogen atom. So the orbits will overlap, and in this case 3 pairs of electrons are shared. 1, 2, 3. Hence, in a nitrogen molecule, we find a triple bond. So, because there are 3 pairs of electrons, this line represents bond. So, at the end of each line there is 1 pair of electron, because in this case there are 3 pair of electrons shared, represented by 3 lines. So, that is how a triple bond is formed, and the compounds so formed are called as covalent compounds. Now, the main difference between ionic compounds and covalent compound is that, number one, covalent compounds have low melting and boiling point as compared to ionic compound. This is because the force of attraction between the molecules is less. So, between the molecules, within the molecule, the attraction is good and the molecule is stable, but between two molecules the force of attraction is very less, poor. So melting and boiling point of covalent compounds are less as compared to ionic compound. That is number one. Number two, covalent compounds are bad conductors of electricity. We saw in the case of ionic compound, they conduct electricity either in the liquid state or in the molten state, because in that case ions are formed. These ions can carry the charge, resulting in conduction of electricity. Whereas in this case of covalent compound, you know that a covalent bond is formed by sharing of electrons. Thus ions are not formed in such a compound. Therefore they are generally bad conductors of electricity, covalent compounds. Another important difference is covalent compounds are soluble in organic solvents, but they are insoluble in water, whereas ionic compounds are soluble in water, but they are insoluble in organic solvents such as alcohol, petroleum ether, petrol, kerosene, etc. So these covalent compounds are soluble in organic solvents but are insoluble in water. They are non-polar, not soluble in water. These are the 3 main differences between ionic compounds and covalent compounds. So here we saw how covalent bonds are formed in hydrogen, chlorine, oxygen, nitrogen. Let us see how covalent bond is formed in a carbon molecule, which we have not discussed. So let us take the simplest example of a covalent bond. This is formed in the case of methane, where one carbon atom is bonded are bound to 4 atoms of hydrogen, resulting in the compound methane. Let us see how exactly this formation takes place with the help of electron dot structure. So we have one atom of carbon. Carbon, you know, it has got 4 valence electrons. We can represent these 4 valence electrons as cross marks, and there are 4 hydrogen atoms involved. So let us represent them, 4 hydrogen atoms, and each hydrogen atom has 1 valence electron. As you already saw, we can represent it using a dot just to differentiate between the 2 electrons. Now each hydrogen atom requires 1 electron to become stable, isn't it? And similarly, carbon requires 4 electrons to become stable. So what happens is sharing of electron takes place. So there is an orbital overlap like this. So this electron is shared with this. This is shared like this. This hydrogen atom shares this way, and overall carbon atom also shares the electrons of hydrogen. As you know, the shared electrons, they belong to both the elements. So thus the compound methane is formed, and here there is one pair of electron shared here, here and here. So we can represent methane using bonds as so that is the structure of methane. This is the electron dot structure for methane. This is the structural formula of methane, that is CH4. So CH4 is the chemical formula for methane. This is the chemical formula. This is the electron dot structure, and this is the structural formula. What exactly is the shape of the methane molecule? So structural formula, we need to make a note of this, the difference between chemical formula and structural formula. And if you observe, in this case there are 4 single bonds, one single bond, second, third and fourth. So in a methane molecule there are 4 single bonds between carbon and hydrogen molecule, making it the simplest carbon compound. So that is how carbon, it forms compounds with other elements, forming a covalent compound by sharing of electrons. Let us now discuss finally what makes it possible for carbon to form millions of compounds. What property of carbon makes it possible? So there are 2 properties. Like methane, we will be deriving more and more structures of different carbon compounds from the next class onwards. So is this an introduction of how a carbon compound is formed. Similarly, if you want to show covalent bond in a carbon dioxide molecule, so we have carbon and we have the 4 valence electrons, Then we have two oxygen atoms. So we have two oxygen atoms, each oxygen atom having 6 valence electrons. And what happens? This oxygen atom requires 2 electrons to become stable, so it will share 2 electrons of carbon. Similarly is the case with the second oxygen atom, and the carbon as such will also overlap, sharing 4 electrons. So ultimately carbon has 4 electrons making it stable, and oxygen atom has 2 electrons making it stable. In this case, carbon, it shares 2 pairs of electrons with each pair of oxygen. So the structural formula for carbon dioxide would be CO2. There are 2 double bonds in this case, one double bond, another double bond, because there is one carbon atom, it is sharing 2 electrons with one oxygen atom and 2 electrons with another oxygen atom, so resulting in a double bond. So that is carbon dioxide molecule. So more such carbon compounds we will study in the next class. Another important point here is the branch of science, branch of chemistry that deals with the study of carbon compounds is called as organic chemistry, because these are naturally formed in nature, organic. So organic chemistry deals with all carbon compounds except oxides of carbon and carbonates of carbon and bicarbonates of carbon. These are not included in organic chemistry. Other than the oxides, carbonates and the bicarbonates, all other compounds are studied in organic chemistry. Even though the percentage of carbon is very less in nature, as we discussed, it still forms millions of compounds. How? Number 1 is the property called as catenation. Carbon, it can form bond with another carbon atom. So this property is called as catenation. We know that the valency of carbon is 4. It needs 4 electrons. So going by that logic, one carbon atom, it can bind to 4 more carbon. And this carbon can again bind to more carbon and more carbon. Thus, due to the property of catenation, as you can see, it can form long chains of carbon compounds. Long chains. These chains can be either straight, or the chains could be branched, or they could be in the form of a ring. The chains can form a ring also. This is possible because carbon can form bonds with 4 more carbon atoms, resulting in formation of long chains. So by looking at this structure itself, you can imagine this would be one compound, this would be another compound, this would be another compound, and you can keep on adding carbon, forming infinitely long chains, making it possible for the formation of millions of compounds. The second property is tetravalency. Of course, we can understand it very clearly. Tetravalency, that is, carbon can bond with 4 more elements. It could be, those elements could be carbon, or it could be 4 more other elements such as hydrogen, oxygen, nitrogen, sulfur, etc. So carbon can form bond with 4 more carbons, or this could be other elements also. So this property is called as tetravalency, resulting in various permutations and combinations of compounds. So because of the property of catenation and tetravalency, carbon can form millions of compounds. This is the important give reason question. Are there no other elements which can form such long chains or such numerous compounds? We have, for example, silicon, because silicon also it has the same property like carbon. Silicon has atomic number 14, so 2, 8, 4. So silicon also has the property of tetravalency. It can also bond with 4 more elements, thus resulting in chains. But in nature, it is observed that the compounds formed by silicon, the chains are hardly 7 or 8 atoms long. So 1, 2, 3, 4, 5, 6, 7, 8. So they form small chains, small compounds, not large compounds. Silicon. Why? Carbon can form large chains, whereas silicon does not form large chains, because these compounds are unstable, whereas compounds formed by carbon are stable. Thus carbon can form millions of compounds. The main reason why carbon forms large stable compounds but silicon cannot form large stable compound lies in their atomic size. Carbon has a small size, whereas silicon has a larger size, of course because of the presence of a extra shell. It has got only 2 shells, making the carbon atom small, whereas it has got 3 shells, so the silicon atom is larger than the carbon atom. So how does it affect the stability of the compound formed? Very simple. Because the carbon atom is small, the nucleus of the carbon atom, it can hold on to the outermost electrons more strongly. So the force of attraction between the carbon nucleus and the valence electrons is strong, thus forming stable compounds. Due to the larger size of the silicon atom, the distance between the nucleus and outermost shell is more, because of which the force of attraction between the silicon nucleus and the valence electrons is less, thus resulting in the formation of unstable compounds. And also the size of the chain is 7 or 8 atoms long, not like carbon, which can literally form hundreds and thousands of atoms long chains. So due to the property of catenation, due to the property of tetravalency, and due to the fact that carbon atom is small, it can form millions of stable carbon compounds with the help of covalent bond formed by sharing of electrons. In the next class, let us discuss a little more about the different types of covalent compounds formed by carbon, or about the different types and classification of carbon compounds. Thank you.